Hello guys, I'm a teacher Limbokan Sajuga Masame. Let us take a look on the question below and try to solve it. Let us consider the bicycle here, which has got the front wheel and the rear wheel and the rear sprocket. Between we got a crank wheel. We've given a number of T's for the crank wheel as n driving T's, and number of T's for a rear sprocket as n driving T's. This side is driven by this crank wheel, hence the effort is applied at the crank pedal here, and the chain between the rear sprocket and the crank wheel is turning the whole system here. The crank wheel, as it turns at the same rate the rear sprocket. This radius, a capital R radius for the wheels, and let us consider for the rear sprocket we have given the capital R radius and the displacement S sub L dash. This displacement is for load because for the rear wheel is a place where load is driven forward after this crank wheel is turning the chains around this rear sprocket. This displacement is corresponding to the displacement angle theta from as seen from the center of the rear sprocket. And then also for the crank wheel we have a displacement S sub E. This displacement is as a result of effort turning the crank wheel, hence displacement is corresponding to the angle theta, and the radius of this crank wheel is small r. Hence this displacement is taken as from the center of the crank wheel to the two successful number of teeth where chains joined into these teeth around this crank wheel. Then let us see the relations that used to calculate the velocity ratio as effort distance divided by load distance. The velocity ratio is equal to sum of the effort distance or effort displacement divided by sum of load distance or load displacement. And then the relation that explains this number of teeth, radius r, and this theta is as you see below. For the effort displacement, the number of revolutions times the radius r times the displacement angle theta divided by number of T's for this crank wheel, that is equal to a number of T's for driving T's. Remember, this crank wheel is the side which drive this rear sprocket by using this chain. And for a load side, we know that the load displacement is equal to number of revolution times circumference of this rear wheel times a corresponding angle of displacement theta dash divided by number of T's of this rear sprocket, which is capital N. Number of T's between two number of T's of this rear sprocket is where this displacement of load is corresponding. Hence the displacement of the load side is greater because of this circumference of the wheel as long compared to the displacement in crank wheel, which is proportional to angle theta. This displacement, which is proportional to angle theta, but the distance between one teeth at the that is corresponding to the circumference of this rear wheel is somehow larger compared to the crank wheel. Hence so the number of turns will be the same for a certain revolution or certain turns, but the distance covered by the rear wheel is much bigger compared to the distance covered by this crank wheel, as the functions of their radius, respective radius. Then we just substitute these expressions into the velocity ratio equations. Then the equations become, as you can see below, the number of revolutions cancel out, number of revolutions cancel out, as long as the chains connecting the rear sprocket and the crank wheel, the number of revolutions will remain to be the same, but the displacement covered by this rear wheel is bigger compared to the displacement covered by the crank wheel. Then we get a velocity ratio as approximately 0.18, while efficiency of machine is equal to mechanical advantage times velocity ratio times 100%. Then we substitute the values as we have given the mechanical advantage, and we divide with this efficiency of machine, this velocity ratio, and efficiency of machine is approximately equal to 77%. Okay, thanks for watching. Please like, share, and comment if possible, and don't forget to subscribe for more video like this one. Thank you.